Good morning, everyone. Today we are going to start chapter 13 of class 9, surface areas and volumes. Before starting this chapter, let me tell you few introduction part of this chapter. Children, you might have heard about, you have learned about geometry, right? Geometry has actually two parts. We deal with geometry, plane geometry and solid geometry. In plane geometry we deal with 2D figures, and in solid geometry we deal with 3D figures, right? 2D figures like triangle, square, rectangle, and 3D figures like cube, cuboid and cylinder. As we all know, 2D figures have only two dimensions, length and breadth, whereas 3D figures have three dimensions, length, breadth and height. And in plane geometry, we always find the perimeter. Perimeter means the length of the boundary of these 2D shapes. Perimeter and area. Area means the surface occupied by the particular figure. So we find perimeter and area of 2D shapes. But in 3D figures, we always find surface area and volume. So this is the main topic we are going to deal with today, that is surface area and volume. Now, what is surface area? Surface area is the total area of the surface of three-dimensional object. So what is surface area? The total area of the surfaces of three-dimensional object. For example, I have this object, this is a duster. So total surface area means this duster has six faces: upper, lower, front, back and two side faces, right? So the total surface area means the surface occupied by these six faces, right? So this duster is also an example of cuboid, right? Cuboid, what is cuboid? Cuboid is a 3D figure whose all faces, it has six faces: 1, 2, 3, 4, 5 and 6. So it has six faces and all the faces are in rectangle. All the faces are of rectangular shape. See, upper face is of rectangle, lower face is of rectangle, then side faces are also of rectangle, and front and back face is also rectangular. So when all the faces are of rectangle, then that 3D figure is called cuboid. So this cuboid has six faces. So the total surface area of the cuboid is area of the upper face plus area of bottom face plus area of front plus area of back plus area of two side walls. So you can see this is the length. This is length of this cuboid. This is breadth. So the area of upper face is LB. Similarly, area of lower face is again LB. L into B. So total surface area of cuboid is area of upper face, that is LB, area of lower face, that is again LB. Then we will take area of front. You can see this front face. So area of front face is L into, this is called height. This is actually height of this cuboid. So area of front face is L into H. Similarly, area of back face is L into H. So area of front is LH plus area of back is LH. Now we take area of this side face. So this is breadth and this is height. So area will be B into H. So area of two side walls will be BH plus BH. So when we add LB plus LB, it makes 2LB, LH plus LH, it makes 2HL, plus BH plus BH, it makes 2BH. So 2 is common. So we are left with 2 into LB plus BH plus HL, which makes the total surface area of cuboid. This is how we can derive the total surface area of cuboid. Now coming to lateral or curved surface area. Lateral means the side. Lateral means side area. Side area means in this curved or lateral surface area, we have to exclude the upper face and the lower face. It means lateral surface include the area of these side walls. First wall, four walls, front, back and two side walls. So area of these four walls will be considered as the lateral surface area of cuboid. So that is why lateral or curved surface area of cuboid will be written as area of four walls. If we want to find out area of four walls, then we have to use the similar formula. So you can see area of this wall is L into H and area of the back wall is L into H. So LH plus LH, and area of this side wall is B into H, and area of this side wall is again B into H. So BH plus BH. So 2LH plus 2BH. 2 is common and H is common. So it makes 2 into L plus B into H. So this is called the curved surface area of cuboid. Now coming to volume. What is volume? Volume is the measure of amount of space inside a solid figure. Whatever amount is occupied by a solid figure is called the volume. In case of cuboid, we can see how much amount of water we can fill in that cuboidal tank. So that will be considered as the volume. Volume is the measure of amount of space, right? Amount of space inside any solid figure is considered as the volume of that figure. And in case of cuboid, you can see this is length, this is breadth, and this is height. And to find the volume of cuboid, the formula is area of base into height. As you can see, the base is rectangular in shape and its area is L into B and height is H. So formula becomes L into B into H, that is LBH. So this is called the volume of cuboid. Now how we come to know that when we have to find total area or when we have to find volume of particular 3D shape. So in case of surface area, you always think about the total area you would have to paint. If you want to paint any area, it means you have to find surface. If you have to do anything on the surface, it means we have to find surface area. And in case of volume, think about the amount of water it can hold, the capacity, right? The capacity, a particular figure, how much capacity of water or any liquid it can hold. In that case, we'll find the volume of that particular 3D figure. Now coming to this next figure, as you can see, this cuboid, this is called cuboid because it's all the six faces are rectangular in shape, right? And when all the six faces are in square shape, that 3D figure, the figure we obtain after joining all the six faces, we get cube. So the main difference in cube and cuboid is that in cuboid all the six faces are of rectangle in shape, and in cube all the six faces are of square in shape. And you can see in square all sides are equal, so here length is A, breadth is A, and height is also A. All the three dimensions will be same. So again, to find the total surface area of cube, we will add all the areas of six faces. Area of front face is A into A, area of back face is A into A, area of top is A into A, area of bottom is A into A, plus area of side wall is A into A, plus area of second side wall is A into A. So you will be getting A square plus A square plus A square plus A square plus A square. So it means 6A square. So the total surface area of this cube is 6A square. And to find the curved or lateral surface area of cube, again we have to take the side walls. So we have to exclude the area of top and bottom. So we are taking area of front and back face, right? A square plus A square, and area of two side walls. So total 4 walls. In lateral surface area, we deal with only the side walls, excluding the top and bottom. So A into A plus A into A, these are areas of front and back. And area of two side wall is again A into A plus A into A. So it makes 4A square. And in case of volume of cube, again the formula is area of base into height. Area of base means, you can see the base area is square and area of square is A into A. Side into side means A into A. So A into A, and you can see height is again A. So it becomes A into A into A, that is A cube. So volume of cube is A cube. This is how we have derived the total surface area of cube, cuboid, and volume of cube and cuboid. So I hope you have understood these formulas and try to learn these formulas by heart, because your most of the your this full chapter is based on these formulas. If you will learn these formulas by heart, then it will become very easy for you to do this chapter. Now coming to exercise 13.1, question number 1 is: a plastic box 1.5 meter long, 1.25 meter wide, and 65 centimeter deep is to be made. Is it is opened at the top. Ignoring the thickness of plastic sheet, determine the area of sheet required for making the box and the cost of sheet for it. If a sheet measuring 1 meter square cost rupees 20. Now you can see we are given the a plastic box has dimensions length, breadth, and deep means height. So it has length, breadth, and height. So length, breadth, height are different. It means it is a cuboidal box. So here you can see length is in meter, breadth is in meter, but height is in centimeter. So convert this centimeter into same unit as meters. Then it is also given that it is opened at the top. It means we have to find the area of 4 walls, right? It means if this is a plastic box, then we have to exclude this top face. So we have to take these 4 walls, front, back, and 2 side walls plus bottom. So how to do this? Let us see. So length of box is given 1.5 meter, breadth is given 1.25 meter, and height is 65 centimeter. So you can see length and breadth are of same units, but height is in centimeter. So convert this centimeter into meters by dividing with 100. 1 centimeter is equal to 1 by 100 meter. So you will be getting height as 0.65 meter. Now area of sheet required for making the box. As I told you, the box is opened from the top. So we'll take area of 4 walls, right? 4 side walls area we need plus area of bottom we need. And area of 4 walls, I have told you what is the formula. 2 into L plus B into H plus area of bottom is bottom. As you can see, the bottom face is having area L into B plus L into B. Now put the value of L, B and H wherever is required. 2 into 1.5 plus 1.25 into height is 0.65 plus L into B in one bracket, 1.5 into 1.25. So after solving, we will be getting area as 5.45 meter square. Now cost of 1 meter square sheet is 20 rupees and cost of 5.45, the area whatever has come of that plastic box. So the cost for 5.45 meter square area is 20, rate multiplied by area, 20 into 5.45. So I have removed this decimal upon 100. 25 is 100, 545 divided by 5 gives 109. So the cost of sheet is 109 rupees. So I hope this is clear. As it is open from the top, so that is why we have taken area of 4 walls plus area of bottom, excluding the area of top. Now coming to question number 2. The length, breadth and height of room are 5 meter, 4 meter and 3 meter. Now it means the room is in cuboidal shape, is of cuboidal shape, as length is 5, breadth is 4 and height is 3. So the shape of room is cuboidal. Find the cost of whitewashing the walls of room and the ceiling. It means we have to find area of 4 walls plus area of ceiling. And what is the rate given to us? 7.50 per meter square. The cost of painting, whitewashing for 1 meter square is 7.50. So whatever area will come, that will be multiplied by this rate. So you will get the total cost of whitewashing. So coming to question 2, length of room is 5 meter, breadth is 4 meter, height is 3 meter, and the walls and ceiling of the room are to be whitewashed. So we have to find its area then. Area of walls of room and ceiling. So area of 4 walls is 2 into L plus B into H. Lateral surface area of room is called the area of 4 walls of room. So 2 into L plus B into H plus ceiling, again you can see the top face of cuboidal room is of rectangle having length and breadth as dimension L into B. Right, now put the value of LBH 543. Right, so after putting the value we get area of 4 walls and ceiling as 74 meter square. Now cost of whitewashing 1 meter square area is 7 rupees 50 paisa, and cost of whitewashing 74 meter square area is rate into area 7.50 into 74. So after removing this decimal we get upon 100, 0 cancels with 0, 75 into 74 gives 5550 upon 10. So 0 cancels with 0, so we get total cost of whitewashing the 4 walls of room and plus ceiling of room is 555 rupees. So this was question number 2. Now coming to question number 3. The floor of a rectangular hall has a perimeter 250 meter. Now it is given that the rectangular hall is a 3D figure. It means that might be in cuboid shape. So the floor of that rectangular hall has a perimeter 250 meter. If the cost of painting the 4 walls at the rate of rupees 10 per meter square is 15,000, find the height of hall. Now it is given that 4 walls, the cost of whitewashing the 4 walls of the room is 15,000 and cost per meter square is 10 rupees per meter square. So we can easily find out the area of 4 walls, because area of 4 walls, formula to find area of 4 walls is total cost divided by cost per meter square. Right, so you can see the perimeter of rectangular hall is given 250 meter and perimeter is 2 into L plus B. It means the value of perimeter is 250. 2 into L plus B is given 250 meter. Now it is given that the total cost of painting the 4 walls of room is of that hall is 15,000 rupees and cost per meter square is 10 rupees. And if total cost and cost per meter square is given, then we can easily find out area of 4 walls, because total cost is given of 4 walls. So from here we can easily find out area of 4 walls. Area of 4 walls will be total cost divided by cost per meter square. So 15,000 by 10. So we get area of 4 walls as 1500 meter square. And area of 4 walls formula is 2 into L plus B into H is equal to 1500. And we already know the value of 2 into L plus B, because it is given 2 into L plus B is perimeter. So its value is 250. So put the value of 2 into L plus B here as 250 into H is equal to 1500. So H is equal to 1500 divided by 250. It gives H as 6. So the height of hall is 6 meters. I hope you have understood. This is very important. Area, if total cost and cost per meter square is given, we can easily find out area. As here you can see, if we want to find out total cost, see, if we want to find out total cost, we always multiply rate with area, and if we want to find out area, we have to multiply total cost with cost per meter square. All right, now coming to 4th question. The paint in a certain container is sufficient to paint an area equal to 9.375 meter square. How many bricks of dimension 22.5 centimeter into 10 centimeter into 7.5 centimeter can be painted out of this container? Now see, the dimensions of brick are given in centimeter, and the paint which has already in a container is in meter square. So we have to tell the paint in a certain container is sufficient to paint an area equal to this much meter square. So how many bricks we can paint from this paint? So you can see, as the total area that can be painted by paint container is 9.375 meter square. So as I have told you, bricks, dimensions of bricks are in centimeters. So first convert this meter square into centimeter square. As 1 meter is equal to 100 centimeter, so 1 meter square is always equal to 10,000 centimeter square. So to convert meter square into centimeter square, we have to multiply it with 10,000. And after removing decimal, we get 1000 in the denominator. 3 zeros cancels with 3 zeros. So we are left with the total area that can be painted by a paint container is 93750 centimeter square. Now let us see what area we will get of brick. And number of bricks we can paint from this area, we have to find that. Dimensions of bricks are: length is this 22.5 centimeter, breadth is 10, and height is 7.5 centimeter. And total surface area of brick is 2 into LB plus BH plus HL. As brick is in the shape of cuboid, so we will take total surface area of cuboid. So after putting the value of LB and H, 22.5 into 10, so after removing this decimal, 10 and 10 will cut, we are left with 225. Again 7.5 into 10 gives 75. 22.5 into 7.5 gives 168.75. so after adding it, we get 2 into 4, 68.75. so the total surface area of one brick is 937.5 centimeters square. Now how many bricks we can paint from this area, from this paint? In a container we have this much of paint, so from this much of paint, how many bricks of this area? One brick has this area. How many bricks we can paint from that container? So number of bricks that can be painted is total area that can be painted divided by area of one brick. So after removing this decimal, we get 10 in the numerator. So 9375 cancels with 93750. We'll get 10. So 10 into 10 makes 100 bricks. It means from this much paint in a container, if a container has this much of paint, we can paint 100 bricks out of that container. So this was question number 4. This is very important question. Now coming to 5th question, a cubical box. Now a cubical box, cubical means a box which is of cube shape. A cubical box has each edge 10 centimeter. It means length, breadth, height all are 10 centimeter. A is 10 here. And another cuboidal box. Now we have two boxes. One is cubical, other is cuboidal. And dimensions of cuboidal box are 12.5 centimeter. Length, breadth is 10 and height is 8 centimeter. Now we have to tell which box has greater lateral surface area and by how much, and which box has smaller total surface area and by how much. It means in both the cases we have to find lateral surface area as well as total surface area of cube and cuboid. So you can see edge of cube is 10 centimeter and lateral surface area of cube. Lateral means only the side walls, area of side walls. So we have 4 total sides, front, back and 2 side walls. So the lateral surface area of cube is 4a square. So a is 10, 10 square is 100, 100 into 4 we get to lateral surface area of cube as cubical box as 400 centimeter square. Now length of cuboidal box is 12.5, breadth is 10, height is 8. So lateral surface area of this cuboidal box is, lateral surface area means area of 4 walls, 2 into L plus B into H. So after putting the value of LVH, we get area of lateral surface area of cuboidal box as 360 centimeter square. Now cubical box has area 400 and cuboidal box has area 360. So 400 means cubical box. Cubical box has greater area, lateral surface area, and by how much? 400 minus 360 by 40 centimeter square. So you can clearly see that 400 is greater than 360. It means lateral surface area of cubical box is more than lateral surface area of cuboidal box by 40 centimeter square. Now coming to the second part, now we have to find total surface area of cubical box, that is 6a square, area of all the faces. So area of each face is a square and we have 6 faces, so area of total surface area of cubical box will become 6a square, and a is 10, 10 square is 100, 100 into 6 gives 600 centimeter square. So this is total surface area of cube. Now total surface area of cuboidal box is 2 into LB plus BH plus HL. So after putting the value of L into B, 12.5 into 10 gives 125, B into H gives 80 and H into L gives 100. So after adding we get and multiplying it with 2 we get 610 centimeter square. So you can see which box has lesser total surface area. Cubical box has 600 and cuboidal box has 610 centimeter square area. So 600 is lesser than 610. It means cubical box has smaller total surface area by how much? 610 minus 600, that is 10 centimeters square. So I hope you have understood question number 1 to 5. Thank you so much.